What I said, I'm Karen Aghoort, working at UMC Utrecht, Psychiatry Department. Glad to be here. Thank you for inviting me to tell you a bit about our Big Data in Psychiatry project. Before I forget, I'm very sorry, but I had to leave after my presentation to Beeldhoven, so I will miss the discussion, but I'm really willing to answer questions or discuss with you. So please, if you have any questions, ask the organization for my contact details, then it will be fine. Thank you. Great. First, why big data in psychiatry? In 2015, we started our initiative, and it was inspired because in psychiatry, things are, we think, more complex than in lots of other diseases. The psychiatric phenotype is very complex. Sometimes a disturbed mind presents it in emotions or disturbed feelings. Sometimes in cognition, for example, people with a psychosis are always suffering, or often suffering from problems with their memory or other cognitive problems. But you also see problems in behavior, very actual in the Netherlands at the moment. People are showing confused behavior and those things. And we still, after all those years of research, do not understand quite well why one person on a specific moment, on a specific situation, is suffering from mental health problems or not. And we think that one of the reasons that is because lots of research is quite unidimensional done in, we call it silos. You have the research groups who are concentrating on the imaging data, the groups who are, for example, interesting in the activity of the brain, the EEG measures. And you have the genetic streams and the researchers who are working in those groups. But the combination is not often found between all those different research groups. And we think that if you really want to understand those complex phenotypes, you really should integrate all types of information. And there are quite severe problems to overcome. One of the problems we think is that in psychiatric research there's a very big selection bias. People with very severe problems often cannot participate in clinical trials because they are too severe ill, they have comorbidity, they are suicidal, so they cannot participate in the clinical trials, and because of that, the results from those trials are not really fitting those patient groups, and you see that lots of treatments based on the clinical trials are not working for those patients. We also have already discovered that the brain changes over time. Brain plasticity, you see the effect, of course, of development of people, but also a quite severe effect of medication in which we have not really the insight how it works at all. And at last, you see lots of influence of the environmental things of a person. Where is one person living? In what kind of environment? Is it a green or a blue environment? Or is it a very urban environment? Is there a lot of air pollution in this environment or not? Now, all those types of information we think you should combine to better understand the complexity of the psychiatric phenotype. And we think that new technology is really bringing the opportunities to better understand all those different influences. For example, wearables can collect information from a patient in his real life. Now we only collect the information or in a clinical trial, or maybe when a patient is following treatment with a psychiatrist, but then the psychiatrist sees that patient in the room, and that's not really the natural environment of that patient, of course. So lots of opportunities. In general, we think that the psychiatry as it is now should transform to a more blended psychiatry, in which you should involve as well the patient story, what's the experience, the real experience of the patient itself, Of course, professional knowledge from the professional learns at school or in his experience, and data knowledge. And that's why that's what I want to tell you a bit more about how we practice this in UMC Utrecht at this moment. We want to learn from real-life clinical data. And of course, this is not the complete puzzle I showed you before, but we are finding all those small pieces to finally complete the total puzzle. Learning from real-life clinical data. So that means that it's from all patients, not only the selected group we see in the trials. We started a pilot in 2015, I guess, with 2 people, one data scientist and me, myself. At this moment, we have a PsyData team from 4 data scientists, which facilitates our departments and all professionals and patients with knowledge and results of data science. So we really grew in the last years. And we collect a lot of different data sources, but our main source is our EPD, or electronic patient records. And that's, I think, 80% of the APR is filled with unstructured data. You also said that that's the most valuable data, so we concentrating also on text mining techniques to better understand all those data. But also information about incidents, aggression incidents, that's also mistakes, medication mistakes, aggression incidents, open information from the CBS about neighborhoods, from the KNMI about weather information, because there were lots of gut feelings from professionals that the weather really had to do with aggression on the wards. We didn't find any correlation, but they were quite strong in their, they were very convinced. And information about geographical data. And from the beginning on, we thought it is absolutely necessary to work closely together with the data scientists and the professional on the floor. Because what we really want to do is we want to make impact with the results in daily practice. So what we did, we organized multidisciplinary sessions with professionals. She is a psychiatrist, he is a nurse, and she is a data scientist. And we analyzed the data together and explored the data together on the screens. And that was lots of fun. We had not any problem to find professionals to do this with us. They really want to work with us on those data. A situation, 2 different worlds meet, and it was very productive. And we are still doing this type of sessions on the floor, but now we have our own data science room, so people come to us mostly on the Wednesday. That's our Data Wednesday. So there is a free come-in from all types of professionals, and sometimes also from patients who have questions to us. It also reminds us about the fact in the pilot our data process was quite, we just linked some data files together, but it was really intensive to do, and we really needed to atomize things. So we asked a startup company, AEGLE, to help us to fill in our data process, and they learned us what our needs were. That was that a data process should be flexible, modular and scalable, usable and maintainable, and fast and lean. And at our own Department of Psychiatry, we have our own data process now. And of course, it's based on the processes at UMC Utrecht, but our central IT department is not that flexible and scalable and fast. So we really wanted to have our data infrastructure more independent from their things. So, and it works. It works. It's still that structure is still what we are using now. That's quite a complex picture, I'm afraid, but this is how we organized our process now. So we got our sources directly from the, we call it in human studies a research data platform, where it's already pseudonymized the data, and detailed data from birth dates, etc., are already deleted from the data. Then it goes in our own pipelines platform system, in which we can parse the data in the way we want. We notice that data scientists always want to use the tools they want to handle, and that they are not letting them tell what tools to use. So we created a platform that is flexible in data scientists who want to use Python, R, SAS, or sometimes even SPSS to use their own tools. We use a Jenkins server to update and automatically refresh the data. We really are used to store our code in GitLab to make it able to share the code and to check the code from each other. And we have tools to visualize the data, because that's very important. If you want to cooperate with professionals, they are often not so used to work with data, so you have to work really with good visualization tools. So that's the process. And some things about how we are working now. We have periodic visuals with business information. It's on the first, but I think this is our last product we realized, because in the beginning we started really with clinical questions and clinical information, but you see that managers from the department, but also healthcare professionals, are also asking for business information. We see lots of ad hoc questions about all kinds of things. For example, professionals were asking about the introduction of our patient portal. I don't know if you know, but all patients can read their own patient records with us since, I think, 2 years. And nurses were quite curious if their reporting style was deferred after the introduction of the open patient portal. What I think that their reports were shorter and more objective. So the nuance is out of the reports, because they know patients can read their reports with them. So those questions come to us as a team. And we are doing a couple of clinical decision support projects, which I will be in more detail in a minute. So this is an example of such a periodic visual, just business information. This is our digital project board, where we collect all the questions people send to us from nurses, from psychiatrists, managers. We all collect them here and show them what we do with the questions. And it's quite interesting, because we, in the beginning, ask ourselves, this is not really big data. Is this really what we should do? Is our team for this kind of questions? And we are quite sure that you absolutely should do this question, because these are the questions that are in the heads of the professionals. And if you want to cooperate with them, you need the commitment of them, and helping them with these questions helps them also to find other questions. And sometimes you think they're more relevant questions, but yeah, I think it's very needed to also do these kind of more descriptive questions together with professionals. Then I want to be in a bit more detail about 2 prediction projects. We have did 2 projects on the prediction of medication effects of antidepressants and also antipsychotics. And for antipsychotics, we didn't manage to find any model for the data. And the reason for that was that we had not a very good outcome measure in our clinical data. We couldn't extract a good outcome measure in the data. For antidepressants, we had a good outcome measure, the Hamilton questionnaire. It's a clinical measure. And that works quite well, and the results are very promising. We found that the model could predict quite well if a medication has a good response for the person, and it also could help the psychiatrist in the choice for which type of antidepressant he should prescribe. We performed a lasso regression analysis for this model, and we find some predictors. I show them here because it's important that we also showed and give some information about what are the predictors and in what way they predict the effect, because that helps the psychiatrist to understand why the model is working and doing what it does. Because if it's only a black box model, it's very difficult for professionals to really trust the model and to use it in daily practice. So that's why we try to really understand the model a bit. So there were a couple of predictors in it, and we found that the model in certain, almost half of the cases suggests another type of antidepressants than the psychiatrist choose. So that's quite interesting. And at this moment, we are already helping the psychiatrist with some kind of advice based on the model. Not that it says you should prescribe this type of antidepressants, but in a more discussion way. So if the model should say you should prescribe this type of antidepressant, do you agree or not? And then a psychiatrist reacts and says, that's strange. I was thinking about prescribing this. Why do you think the model is saying that? Now, I think that that's the way the model is getting better and better. And our next step, what we really want to do, is to validate this model in other institutions, to find if this model is also working in other mental health institutions. And if we find their good results, then it's ready to bring in practice, I guess, but not yet. It's more in a discussing way. Other project is about the prediction of aggression before admission. Very impactful, of course, aggression on the ward, as well on patients as well on professionals. What we tried to predict was if aggression will occur upon the day of admission. And we only used in the analysis clinical text which were already reported in the electronic patient records until the day of admission. So that are, for example, reports of the intake or reports from earlier admissions. Those clinical texts were firstly, and all clinical texts, of course, in our process, are firstly anonymized by the deduce method. That is developed by Vincent Menger. He's a PhD student on this project. It's completely open source, so everyone who wants to use this tool to anonymize clinical text data can use this. He analyzed the data by deep learning methods, and what was quite interesting is that his results he found on the model are better than the clinical questionnaires we now use to predict aggression on the ward. So normally those questionnaires are in 70% accurate, and the model is in 80% accurate. So that's quite a good improvement, we think. And if you really can make use of already filled-in data, it lowers administration, of course, on professionals, which is very important for them. A paper about this is already submitted. Okay, then a big challenge. Because you can organize these kind of things on your own department, as we do. But what you really want is to learn together from all the data and the models and the tools, also on other institutions and other groups. And that's quite difficult because sharing data is difficult because of all types of privacy problems and differences in systems, etc. So what we suggesting is a compute visits data model, which we want to test and are going to test in a funded project from ZonMW, together with 3 other mental health institutions, the Psychiatry Department of St. Antonius, GGZ Eindhoven, a big mental health institution in the south of the Netherlands, and Antes GGZ, which is located here in Rotterdam, and also a very big center. And together with the University of Eindhoven and Utrecht, we are discovering if you can find a method to really share knowledge, to share tools, algorithms, results together in order to learn quickly from results. We are planned to do it in a kind of carousel model in which one institute starts with a theme. After maybe 3 months or 6 months, the theme goes to another institute who works with the results Institute 1 has found, and then that's continuous, a loop. So that's what we plan to do, and more in detail you could see it like this. If you want to find a personalized medication profile, now we already developed a model on the antidepressants. Then in this way, GGZ Eindhoven goes on with this model, it validates that, it replicates them. We think that there are some generalistic parts in the model, and there are some parts which are really location bounded, because every location and every institute has its own population, of course, and maybe has their own clinical practice things they use. And very important in that we do not want to share data, we only want to share algorithms, expertise, tools, in order to facilitate a quick sharing of knowledge. We think this is really a big challenge, but also really gives lots of opportunities from sharing and benefiting from the knowledge in data in the whole Netherlands and the whole psychiatry in the Netherlands. This was what I wanted to tell you now. Thank you very much. Thanks to the persons and the PsyData team at UMC Utrecht, AEGLE, Informed, and PACMed, who are organizations we worked with on these topics. And I have some time for a few questions, if that's possible. And after that, I'm very sorry to leave. Thank you.
Thank you for your lecture, quite interesting. I'm from clinical chemistry, Erasmus.
Okay.
And so I'm wondering, you're talking about a transition into clinical practice or into a more general practitioner sites. What's your timeline? Can you say something about it?
Yeah, the funny thing is that we are already, I think we already changed in UMC Utrecht Department of Psychiatry from a more knowledge organized organization to a more data-driven organization. And that development has been quite fast. I think 2 years we are busy now, and of course not everyone, that's difficult. Not every professional or every patient thinks, wow, data is our new thing. But I think this can be quite quick. I think in 3 to 5 years, daily practice, daily clinical practice can be much more data-driven than it is now. Maybe I'm too optimistic because, of course, I'm now working in an environment which is quite open to this kind of developments. But yeah.
Because the data you use is different from data in another sense.
Yeah.
So the algorithm is not really a one-to-one.
That's the big challenge. Yeah. Yeah. Maybe there you need some kind of meta level between the clinical data in Center 1 and in Center 2 to match those data, the clinical data. Yeah, but that's the research question we need to answer. Yeah.
For me, that is also very interesting, the way you presented the distribution say, validation. But then the next step would be to move on to also some way of distributed learning, because you don't want to share data, you want to
share
somehow the algorithm, but this algorithm should learn on the distributed data.
Mm-hmm.
I guess in the future you would want these 3-4 institutes to collaborate in new models.
Yeah, but we think that, of course, every new patient in your institute is generating new information. So you create learning models in your organizations. Yes, that's right. Is that your...
So there is an initial model that is built somewhere and then this evolves through the data.
Exactly. Yeah, exactly. Yeah.
How do you anonymize your patients, or is nothing anonymized, is directly coupled feedback into your healthcare system?
So we the personalized information is deleted, like the BSN or the birth dates, etc. So we only have some kind of how should you say, a patient number, but not the patient number we use in the hospital, but the pseudonymized number. So we can see which tables belong to the same person, and the anonymization of the text fields is based on tables with names, email addresses, institutes, telephone numbers, etc. And those are removed from the data.
How do you feed it back to your clinician?
How? Now we, that's a good question. But at the moment we have not a direct connection between our data system and the electronic patient record. So it's an advice the data scientist gives to the doctor, and the doctor says, okay, this is patient X. Then we find out who is patient X, and then the information goes back to the doctor. So not in the APR. It's a system which is not connected at the moment. But in the UMC Utrecht, they are developing now a clinical decision support layer in the data, which should facilitate those kind of activities. But I'm afraid that will take a year at least, yeah.
Delusions in people with schizophrenia seem to be affected by their environment, and I read recently about somebody developing a smart pill for schizophrenia to monitor their compliance. Does this sort of monitoring that occurs in research, does that affect persecutory delusions in people with schizophrenia? Because obviously they might think everyone's watching them, and then they find out they are being watched more. I know, of course, we've got to do research.
Yeah. In fact, that we already experimented a bit with wearables, and there were patients that are really getting more paranoid because of those tools. That's absolutely true, and so it's not working for all types of patients. Yeah, that's right. So you also will have a kind of selection bias using those tools. That's right. Yeah. But not as much patients as professionals in the beginning thought. So it was not that severe.
Okay, thank you, Karen.
Okay, thank you very much.